Everyone, welcome to Baozi Training Leetcode solution. If you want the best mock interview experience in North America, feel free to check us out at baozitraining.org. We're here to help you land your next dream offer. Before we talk about today's problem, I just want to say, today is Monday, August 5th, 2019. So for the past weekend, there are two massive mass shootings in the U.S. One is in Texas, El Paso, and then the other is in Dayton, Ohio. I think combined like 29 people died. It's really, really sad, and it's been kind of like a constant thing here in the States. I just hope everyone is safe. I really, 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 really wish everybody is safe and just take care of yourself. Cool. Nothing like lead coding or finding your next job, nothing can be more valuable than your life itself, right? All right, so let's get to this problem. It's a relatively, again, I've been getting a little bit lazy these days, so I was only looking at the easy problems. Well, sometimes, when you feel like you are a little bit busy or you're not making too much progress, you can always go back to the easy problems just to regain that kind of confidence. It's like if you're doing bench press, right? It's always, you push your limit, and then it's always good to actually retreat back and then just keep doing more sets just to pump your blood and keep things going. Okay, today the problem is balanced binary tree. It's very simple. It's giving you a binary tree, determine it is a height balanced. So what is height balanced? Height balanced means a binary tree in which the depth of the two subtrees of every node never differ by more than 1. For example, this is 1 because left subtree height, let's say, is 1. This is 2, always like this. This is not because, if you look at this subgraph, is still balanced. But if you look at the entire tree, so for the right subtree, the height is 1, and here is 3. 3 minus 1, which is 2. That is not a balanced one. So as described for this problem, it should be at this moment, it should be very intuitive for you to think this is kind of like a recursion problem. So all you need to do is you just keep going. Let's say you're going left, and then you're going right, and then you can have the height of the left subtree, you can have the height of the right subtree, and then at this moment you can calculate, are they actually bigger than 1? If it is bigger than 1, that means it's not balanced. It's what I normally call a very typical post-order traversal in those kind of problems. Remember, there's 3 traversals, right? One is pre-order, which means you can easily think about you do something first, and then you go to the left, and then you go to the right. In order traversal, for example, you always go to the left. You can also always go to the right. Let's just assume you always go to the left first. You do a bunch of things. Now you always go to the left. After you finish the left, you do a bunch of things, and then you go to the right. So that is called in order. It's like in between. Post order is already processed your left subtree, left part, right part, and then you are doing your stuff. For this one, like I said, you always go to the left, find the height. You go to the right to find the height, because the tree's height has to be non-negative, right? If you already realized, okay, if this is not balanced at all, you can always return -1, so that as long as either of the subtrees is -1, you just directly return -1. So it's just simple as that. Doing something on the left, doing something on the right, and then do some logic. This is a typical post-order traversal. Oh, this sign is not correctly converted. The time complexity of this is O(n), if n is the number of tree nodes, because you visit every tree node once and only once. Space complexity O1, no extra space is needed. Very simple problems for trees. Think about the traversal order: pre-order, in order, and post-order. And also be safe. Be cool. See you guys next time.